setting up, you actually have a picture this time. However, it's the weird case. Let's see how you guys do. And then we're going to compare it to the one that we saw yesterday, figuring out what's the difference. So many different things today. What's going on? Party's all over the place. All right, so notes open, law of science. This is SSA. Calculators open, making sure that we know how to use them and that they're working. Some of you guys were working on homework last night, and maybe your calculator was being difficult. Or maybe you thought it was your calculator, or maybe it was you. I need you to have it here in class doing examples so that when you get stuck, you can say, look, see, I typed it in. What went wrong? Because most calculators aren't going to go wrong if there's supposed to be an answer. Now remember, I said if there's supposed to be an answer, meaning some of these are impossible triangles, but if you're getting more than like one or two, maybe it's you. But it could possibly be a little something that needs tweaking on your calculator. How many of you guys last night used that fraction feature, the alpha, y equals? Two? Hopefully we use it today with the law of cosines, or else we're going to be in trouble. We're finishing law of sines, starting law of cosines. If you don't remember what I'm talking about, the alpha, the y equals, if you weren't in class, that's how you get that little fraction bar, which is for everybody's calculator basically but Vanessa. She just has to use lots of parentheses. It'll make life a lot easier. Law of sines. Is it a hard formula? Yes or no? Yes. Nah, it's not supposed to be. Why are there a couple different ways of doing it, though? Why are there two different variations on the law of sines? Are they really the same formulas? Yes. So what's different about them? Yeah, you can say flip, you can say the orientation, you can say how it's ordered. All different good answers. So, notes open. You need to make sure that your calculator is working, that your brain is working, and that the plugging in is working. And we're on the ambiguous case, the weird one. For notes yesterday, there were 3 different options when you're given an SSA or an ASS. Doesn't matter. If you want to remember it the other way and be like, whoop, that's fine. Whatever makes you pause and think. There were 3 different options of solutions. Could be 0, could be 1, or could be 2. Yesterday we saw 2, but we didn't see how. So we're going to solve another SSA, and then we're going to compare and contrast and try to figure out why did the other one have 2 possible ways of working out compared to this one. What have you guys done so far? Help me out. Fill me in. At the very beginning of class, kiddo. Go. Those of you guys that are awkwardly sitting quietly, I have a question that I'm still waiting for an answer on. How did you start your formula when you were plugging and chugging? Okay, what did you guys put up first? Has to be sine of b because? Over. Wait, it's over 12, right? Because we need b to go with b, and we can't do anything c because we know nothing c. And so then what has to go on this one? So why did you start with the sine instead of the side? Because you were missing an angle. If you pull it out, John, on the left-hand side, there should be extra space. Now, if you set it up like this, what is the easy algebraic step to do to solve? Cross multiply will probably make it even harder. Cross multiply will probably, oh, it's too weird. cross multiplying probably actually make it harder. To be honest, if you set it up like this with the unknown guy in that top left-hand corner, all you gotta do is multiply. If you did it the other way, well, you'd have to multiply and then divide, and then I think multiply again. No, maybe just multiply and divide. But if I multiply by 12, if I multiply by 12, even if you're not doing the nifty fraction thing, it should be working out just fine as long as you end your sign. Some of you might not be ending the sign in the proper place. But are you done yet? Inverse sign, good. You need inverse sign on this guy to get rid of the sign. You need inverse sign of the whole thing. So what is the most efficient way to use your calculator to solve this problem? How many steps would you need to do? How many entries would you guys have to do in the way that you're solving? Good. I would only have to use 1, 2, but just a few of you are doing like 2 or 3 or 4. Because you're doing like a division, then you're doing enter, then you're doing a multiplication, you're doing enter, then you're doing sign inverse. That's taking more time. We can get you using your calculator efficiently. Man, that would be a nice thing. Now, what if you had typed everything in, because you had multiplied to the other side the 12. So you had 12 sine 42 over 22. Maybe you even did the really nifty notation. Oh, that's sine of 42, right? And what if you then realized, man, like I should have done the sine inverse. How can you put it in? Get it. Well, first of all, I think that'd be a nice thing for you to go ahead and use your fraction thing that you're not using. Okay. That's not the answer, no, but that is the fraction. That is going to be what I have. What you're doing, Diego, is you're ending your parentheses too early. Your calculator has the ability to have the nifty fraction. My calculator of yours and update the operating system. But in the meantime, you need to make sure that when you plug it in again, you cannot end the sign inverse parenthesis until the very end. That's what I noticed when I was first looking at it. Second sign inverse, some of you guys, and check it. You have an initial parenthesis, and if you close in your numerator, your denominator, you have to make sure you don't accidentally put one too many parentheses, because if you end the sign inverse early, sign only is allowed to come back from, or sign inverse is only allowed to happen between values of -1 to 1. And if you end the parenthesis early, you're saying only take sign inverse at the top, or only take sign inverse of 12, or only take sign inverse of, you need it to be sign inverse of the entire thing. So if worse comes to worse, what you could do, like Vanessa, you got the fraction, like you just put the fraction in. You could have also done the fraction, made sure you got the fraction, and then done sign inverse of it. So if any of you guys are getting quit, like syntax error, I think you're putting in maybe parentheses a little too early. You got to make sure that you keep that whole thing. Now, if you use my nifty fraction thing, it's actually quite nice because it's really obvious that you have the parentheses in the right spot. But if you're using like just typing it all out with a division sign instead, it can get kind of dangerous. So you might want to do the fraction first and then the sign inverse. Good question, both of you guys on your calculators. The final answer, if you're in, good. You guys get 21.406? Now here's the dilemma. Yesterday, didn't I say that there was technically on these guys an or that you had to think about? Do you remember how I said, now, we went ahead yesterday and we said, okay, let's go ahead and finish the triangle. What is angle C? What is side C? And we finished. But what was that big old or that we had to go to a separate page and say, angle B could also come from? What was that thing that we did? Two solutions. We were checking for two solutions. That was the point. But what was the math that we were doing? Should be right there in your notes, right above where we are. We had B, and then we got another one. We were looking for an obtuse because we got an acute the first time. We were looking for an obtuse. That's good. And how did we find that other option? You're looking at me like I'm going to magically just give it to you. It's in your notes. Look right above. The last example we did. What did we do? Yeah. So where's the rest of you guys? All you have to do is look up in your notes. Nathaniel, let me check real quick. Exactly. Turn it off, put it down, put the cover on. So if you're not using it properly, you shouldn't have it on. 180 minus sine inverse of all the stuff we just did, all the blah, 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 of the 12 sine 42, all over 22. So angle B could also be, well, we just go ahead and if we have our calculators out, we can just do 180 minus what we just found. Oh, I haven't gotten it yet. I was doing it on here. For those of you guys that can scroll up, it's perfect, it's easy, it's no big deal. Now this is a little weird because 180 is also how many angles are in a triangle, but that's not what I'm doing. I'm not finding angle C right now. I'm not adding the initial 42 with the new 21-ish and figuring out the third angle. I'm just saying we have to, for an obtuse triangle, say what if it was acute? Okay, cool, sine inverse. What if it was obtuse? 180 minus sine inverse. It could have been on either side. And so this one gives me 158.593. 594. 158.594 if I round. Remember, once again, I'm a calculus person, and AP people make us round to 3. Your book makes you round to 2. My question is the following. Once you have that piece of information, brains engaged, pencils don't need to be moving. I just want you to ponder what you see. Are both B angles actually possible this way? Why not?
Because B is not an acute angle.
Why? In this picture, yes. So you're assuming that the picture is appropriate. So give me, now Nathan, it makes sense. And others of you are seeing it too, right? Like it needs to be acute. Well, why does it need to be acute? Why couldn't the picture be wrong? Yesterday we said you can draw a triangle and not have it be precise. Exactly. 3 angles in a triangle have to add to 180. What side are you seeing that she's saying? What's 200? Because 42 is stuck. 42 has to be in my triangle. That was a given piece of information. 42 was required. Can 42 and 21 leave room for a third angle? Definitely. Can 42 and 158 leave room for anything else? No, and besides that, it's too big anyway. It adds up to more than 180. So what case is this? A 1 solution. There's only one possible solution. So let's go back to the one from yesterday and see, okay, so what was the difference? This is only a 1 solution. If you finish solving the triangle, which would be pretty basic at this point, once we have 2 angles. So we can do a lot of science the old-fashioned way, like we did yesterday, the ones that you guys thought were pretty easy. But what was going on with this guy that there were 2? Could 34 and 20 leave room for a third angle? Yeah. Yes. But could 145 and 20 also leave room for a third angle? Yeah. Well, you might be like, but why? In this one, Nathan, number 1, I didn't do a picture. But the reason I didn't do a picture is because I didn't want to establish in your mind, like the one you just saw, that there was only one possible way. Let's look at this real quick and see what the difference is. So this one, we do have 2 possible solutions. We have the ones that we found yesterday for the first case, and then we have the actual, although we didn't finish it, I don't think, and then side C. And we would have gotten that third angle just from subtracting from 180. I'm sadly using rounded because I hadn't solved everything all at once. So I'm introducing some error that I wish I wasn't, but that's okay. As far as getting the main idea across. There was room for all 3 to make a triangle, and then we have our awkward other sides, not awkward I guess, but our other sides that are like, how can you make 2 triangles at the same time? Well, what if I was to go get my nifty-difty electronic protractor? What's the angle that I know has to be in this triangle? Yeah, 20 degrees. So I'm going to go ahead and come spit out a 20-degree angle. So let's get 20 degrees over here. Got them. And then let's get 20 degrees over here. Got them. Okay, so I know this has to be in my triangle, right?
I also know that, well, this is where it gets a little sticky and a little tricky because we don't necessarily have triangles memorized by A's and B's and C's. I mean, we can draw it and we can show it, but A's and B's and C's get a little tricky as to who's what and who's where. Remember, the same letter is opposite the angle that you're looking at. So in both of these, I have angle
A being down here in this bottom corner. And so I have this little 3 guy who's supposed to go opposite, but I don't know where he's going to go until I figure out how long this, okay, well, hold on. If I make this, for instance, an A, B, and I don't know where it is, but C triangle, then A would be over here, B would be over here, C would be down there. Okay, so I need this guy to be 5. So I'm going to make this a unit of 1, just because there's 1, there's 2, there's 3, there's 4, and there's 5. Okay, so I have this being a length of 5. There we go. And I know that this side has to be there, this side of 3 has to be there. Sorry, this side of 5 has to be on this side of the 20-degree angle. I have no clue what side C is as far as how long. And I have no clue as far as angle C or angle B. So the only other piece of information I have is this 3. And this 3, okay, I can go ahead and just draw it right above. 1, 2, 3, so that's about accurate as far as the units. I know this needs to come somewhere over here. And it needs to connect at this point right here. But how does it connect is the question.
I'm going to come over to my computer where I can rotate it. How does it connect is the question. So if I was to go ahead and bring this guy and I was to rotate him, how could I rotate this if it was a stick, if it was a string, if I had given you like a length of 5, a length of 3 today? Could I eventually get it to connect? Oh, too far. What am I trying to connect it to? This bottom guy. The side C that I don't know how long or how far he is. But will this guy eventually connect? Yes. But this is what? The acute triangle or the obtuse triangle?
This is the acute triangle. So I have the length of 3. If I just rotate him 1 and 2 and 3, he will eventually meet, oh, there you go, at the acute angle. And that's what I found the first time. That's the 34.75. And I can go ahead and finish solving that triangle, which we did over here. And we know that C would be super long, 7-ish, compared to the 5-ish and the 3-ish. Is that one case? Yes. But the problem is, how could I have gotten that guy over there?
Did I have to stop rotating where I did is the real question. Or was there another way? I'm going to go ahead and make him yellow just so we can see him. Did I have to stop rotating there? Was that the only way to make a triangle? And the answer is no. Because isn't this an obtuse angle, 145? And isn't it actually a really obtuse angle? Could I have kept rotating to make another triangle? And the answer is yes. I didn't have to connect here. I could have kept rotating, connected here with a much shorter C, if you guys kept solving, with a much shorter C and a much larger angle. And there's my 145.25. And that's why it's ambiguous. Because all I know is this angle is set and this side is set, but this other side, well, you could rotate out, you could rotate in, and there are 2 different options for my different triangles. 80.
So when a problem like this arises, we just solve for both obtuse and acute.
And the nice thing is, you try for both. And if it's possible like this, and there are 2 solutions, you don't know which one they mean, so you say both. And in the book, it'd be like an or. And both answers would be necessary. But if you were to plug into something like this one, well, hold on. Why did this work? I know the math didn't work. But why doesn't my idea work? The acute one joins out. The obtuse one says swing in. But what do you notice? A is longer than B. So I would have to actually go past B in order for A to connect way out here. And all of a sudden, I would have lost the 42, so it's impossible. So if it's short enough, it can swing in. If it's too long, it won't. One solution. So you can actually kind of draw the picture, a few of you guys, and figure it out. But the math is super clear, too, if you understand what you're looking for. You're always doing the 180 minus, like you said. to check the other option of B. And you can always compare it and say, well, you have to be true. So does it work? No. Does it work? Yes. Cool. But don't you guys remember there were 3 options? 2 possible triangles. 1 possible triangle. What would be a 0 possible triangle situation? Kimi, what's your question?
Every time I do sine inverse of sine, it doesn't work except for the main diagonal.
Okay, that means whatever you're putting into the sine inverse is too big. Let me show you real quickly how mine could have come up with that. If I had done this guy up here, this exact same problem, and let's just see if it's your problem. If not, I'll come back and look. If I was to do 12 sine of, I think this is, Diego, what you were doing, 42, and if I accidentally did too many parentheses, if you notice, I ended my sine inverse before dividing. I'm going to have that exact same thing because, remember, sine inverse doesn't work if I have bigger than 1, less than -1, and I have left that division off until after the sine inverse. I have to make sure all of my argument is grouped together to make it work. So as long as you have it all, oh dear, the O button. That one's rough with the parentheses. As long as you have your parentheses correct, which I'm guessing you're trying to do like numerator, denominator, kind of like I was showing you. You need second insert 2 parentheses here to begin. Then you can have your numerator. Then you can have your denominator. And now all of a sudden it works. Try that, and if it still doesn't work, then you come back and look. But yeah, that's a main reason why I have calculators in class today, to make sure it's working. And make sure your degree knows that wouldn't make it. Now, hold on. She just brought up an issue, though. Sometimes your calculator with sine inverse doesn't work. So far, all the ones people have brought up, I'm like, oh, it was supposed to work. Nathaniel, make sure you're tracking. Last warning. But I just asked, well, wait a minute. There is a time when it's 0 solutions. Can I give you an example of 0 solutions? And then I'm going to have you guys ponder why it's 0 solutions. Is that a 0 solution? No, that's not a 0 solution. Here. Okay. What if I was to give you something like, I should do a little bit of math to make this example, and I can't necessarily do it in my head. So let's make angle A, just because that's the easiest one to have as far as in your mind and in the picture. Let's have angle A be something like 42 degrees. We did that one. Let's do 49 degrees. I know, it's not that much different. Let's have side B be 15. And then let's have side A be 9. So similar to the one you just did. So similar. You can figure out why is this a 0. Just try putting it into your calculator. He said I did this on all. Justin, she's going to remember you'll see why. But then you should go back and check the other ones that wasn't working. Because now I think your parentheses are okay. But double checking before you. Alright. You guys hopefully set it up really similar to what we did just a second ago, right? With 49 being over 9. Sine of 49 over 9. And then sine of B over 15. What'd you guys do with that 15? Multiply it to the other side. Make sure you're ending your sine around 49, or else it's going to be a little bit funny. But you still have to get rid of the sine, so what are you doing to both sides? Yeah, inverse sine, good, good, good. Good terminology too. So your angle B was equal to make it all nice, neat, and pretty, sine inverse of 15 sine of 49 all over 9.
of what happened when you plugged it in, even with correct parentheses. Domain error. This was an appropriate one because this is not a possible triangle. If you had done a really cool fraction thing, it still said impossible. If you had done the parentheses perfectly, it still would say impossible. This isn't one where you made a mistake in inputting or the calculator didn't understand you, which is really still you making a mistake in inputting. But this was one where it was truly impossible. But why? What's the difference? How did I figure out what to make an A that wouldn't work? What I did is I used SOHCAHTOA. And the reason I used SOHCAHTOA was because if you ever have an angle, let me spit out a 49. Where's 49? 49. Oh no, it's awkward protractors just sitting in the middle of my page. We'll move them over here. Okay, if I have a 49 degree, and if I have a length of 15, which is going to be a little bit annoying for me to model, but not too bad, I'm going to go by 5s just to make it easier. If I have a length of 15, okay, so we'll go by 5, 10, 5, 10, 15. Okay, we'll say that's 15. That's how long that side is. Remember, all of this is stuck. I can't change the 49. I have to have it. I can't change the 15. I have to have that. How did I know that I could make it 9 or 10 or 8 or 7 or 6 or 5 or 4 or 3 or 2 or 1 and have it be too short? It won't ever connect. Because if I was to go here, the 9 is about 10, right? I'm going to go 10, a little bit shy. And then I'm going to go and take this over. Remember, I just said 10 didn't work either. But did you guys see me drawing a picture over there and measuring lengths and trying to figure out what works or not? Or did you see me on my calculator? No, were you watching me at all? When I was making the question, I was on my calculator. I wasn't measuring lengths. I wasn't picking out like sticks. I wasn't trying to figure out, hey, is this going to work or not? How did I know it was going to be too short? This is a key for 1 or 2 of your homework problems. How did I know it was going to be too short? I could swing it. Oh, now it gets farther away. It gets farther away. It's too short, but why? What's the shortest distance between any 2 points? Straight line. How does that work in this context? I need to get from this to this. What angle would I need to go at to make the shortest distance? A right angle. So the shortest distance, what I was doing up here is I was doing SOHCAHTOA because I was pretending it was a right triangle. And I was figuring out what would this opposite be, which I could do sine of 49 is equal to opposite over 15. And I know the shortest possible side that I could have would be 15 sine of 49. And when I plugged that into my calculator, that's what I was doing up here. I got 11 point something. And I'm like, oh, I just have to make it shorter than that 11 point something. And it's going to be an impossible triangle. Is the book going to sometimes is 11.321? I found this, so I made the example back. Is the book going to give you some? Yeah, every now and then. But what's the only time it can give that to you? An SSA or an ASS? An SSA. Because that's the only time that you have options as to where this guy goes, because you only know one angle that's fixed. The rest of them are fluid. So anyway, that's how to have a no solution one. Now here's the struggle though. Your calculators, you need to make sure they're working right now so that when you go home, if you get a domain error, you know it's like an actual doesn't work impossible, as opposed to, oh, I just made a mistake. You have your odds in the back to kind of keep you honest just a little bit. Kimi, did you go back? Did it work on the earlier ones?
Yeah. I guess someone else calculated it.
Oh, got it. So then you didn't even notice. Got it. Yeah, so yours, it was just one of those 2 short cases. I eyeballed it, but I guessed, and it seems, yeah, it's going to be too short. Guys, let's not really stress about this one. That was just another example. Maybe we'll go and do that one another time. I think it's going to be a little like a 2 solution one just to give you extra practice. But there is this chart in the book that might be helpful for a homework problem. I don't remember. There are 2 or 3 homework problems that this chart could be helpful for. It's not on a test necessarily, but it kind of just shows you exactly what I just did as far as the illustration of there's your fixed angle, here's your fixed side. This other one, though, is fluid because you can kind of see it swinging in or swinging out. Or you can see like, hey, it's way too long to swing in, so then there's only one case. Or, oh, it goes straight down. It must be a one case right triangle. Or it's too short. It's going to dangle. Like, there is a chart that has to do with that. I think for honors, I gave them all of those kind of tricky abstract questions. I think for you guys, I only gave you like maybe one. But just letting you know the chart's there and it's good and it might be helpful. But if you have the concept, you don't necessarily need to memorize this. It's more about plugging in to law of science and just asking yourself what's happening. And just being aware that if it does work, you do need to check 180 minus for SSA, because there could be that other can come in and be obtuse, or it can swing out and be a cute option. But sometimes it doesn't work, and hey, sometimes it's just not even possible to begin with. To end off this section, guys, it's a really easy page in some ways. It would be really hard if I didn't give you the formulas. Really hard. It'd be a geometry problem. But in section 6.1 and 6.2, there's a law. This one's law of science, 6.1. And there's an area formula. And then in 6.2, there's a law of cosines. And then there's an area formula. And the reason there's an area formula is because with right triangles, area was easy. Because what's the area of any triangle in general that you guys remember from geometry? Area of a triangle is 1/2 base times height or altitude. And in a right triangle, what are you always going to have? The height. You're going to have the up. You're going to have the altitude. It's easy. It's just that opposite side. You're always going to have the height and the base. But what's the struggle as soon as you get to obtuse triangles? Where's your height? Outside the triangle for an obtuse. Or inside the triangle for an acute. So now it's super annoying because you're like, I don't know my height because you didn't give me a right triangle. The nice thing is there's a way around that. The way around it, though, is knowing the area formula or knowing your geometry. You could just memorize, hey, if you have an angle, all you got to do is 1/2 the sides on either side of the angle times sine of the angle. That's why you could think about this as an SAS area formula. If you have SAS, side with an angle with a side where the angle is sandwiched, you can always just throw into this formula and you'll have the area. But if you're one of those curious types, as the rest of your class is writing down what it is, I can show you where it came from, because we could talk about this as a little baby right triangle with this guy being 52. With this guy being our unknown h, we could do a quick geometry. Two angles are supplementary, so this missing guy would be 180 minus 102, which would end up being 78. So we could go ahead and do a sine of 78, which is that angle on the other side towards the altitude, is equal to opposite, the guy I don't know, over hypotenuse, the guy I do know. I could actually figure out my height with a quick geometry setup. And then I could do my old-fashioned A is equal to 1/2 base, which I know is 90, times height, which I know is 52, sine is 78. Just a couple of you curious ones are like, wait a minute, that's not the formula. The formula uses the 102. Well, but in this section we talked about SSAs, where sine is the same thing in the first quadrant, which would be that sine inverse. Sine is positive here, but sine is also positive here, which is that 180 minus sine inverse. So both of them are options because the signs are the same. The sign of the supplement is going to be the exact same as the sign of the original. And so technically, because of that, we're able to actually have a simpler formula that doesn't even need you to go looking for 180 minus. It allows you to use that very given angle. Just because of sine. That's why it's in 6.1. Not so much because it's law of sine. It's not. It's just a cool property of sine that we've already talked about with that ambiguous case. And then we would just plug each other. And guys, you shouldn't be getting any errors on this because there's no sine inverse. Only sine inverse says I only work sometimes. Only like trig inverse, I should say.
only works sometimes. Otherwise, you should be good as long as you're in the proper mode. And if you haven't been bringing your calculator to class, please make sure you're in degree mode before you do homework, or else it's just going to be a bummer. All right, that's law of sines, and that's the area using sign. We're not going to get like deep into law of cosines. I just want you to write the law down. Which, if you're like, law of sines is short, this will be fast. Law of cosines is a little more complicated. Not impossible, it's just a little bit longer as far as the formula. That's why we're going to write it down today so we can use it tomorrow after we grade our law of sines homework. So I'm going to go ahead and zoom in. Let's zoom in some more. Yeah.
What would you do if they gave you degree of A and sine of A and asked you to find B?
But is that where it's asking you to find B such that you have two triangles, one triangle, and no triangles?
Just as find value of B.
It doesn't say 0, 1, or 2?
Oh, one solution, two solutions.
Oh.
No solution.
Okay. The solutions are the answers, aka the number of triangles of the same thing. I'll give you a hint as to where to start. I would think about what if it was a right triangle. Because that's the most basic, and then you have to kind of generalize out from there. So you could go ahead and say, if it was a right triangle, you have to start there. That would be a one solution, right? Because there's only one way to put all of that together to be a right angle. So that could be one answer for one solution. And then, as we just talked about, if you know the right triangle, don't you know how long it has to be? So if it's any shorter, it would be 0 solutions, right? And then for two solutions, well, we'll talk about that tomorrow when we go over homework questions. But what do you have so far, Kimia? I'll help you think about the right triangle. What's your angle A? Sorry.
36.
Okay. And then what's your side? Someone on their phone, please. Turn off the phone. If it was a right triangle, it would be H. And so then I could go ahead and just do a quick SOHCAHTOA. Sine is opposite over hypotenuse. So for one solution for a right triangle, which there's also another way of having one solution, it's if it's too long, and so then it can't swing back. But one solution would be at the right triangle, which would say sine of 36 is equal to h over 5. H over the 5 can go to the other side. So if I figure out that value of h, that's one way to have one solution. If h is less than that, it's too short and it's going to dangle and it's going to be an error when you try to plug in. But you have to think about, okay, but what values could it be such that it could swing in and out? That would be 2. And then what values would it be too long that it can't swing in anymore? It can only go out. That would be the other one solution. So anyway, that should get you thinking at least. There'd be like a greater than, less than for the two solutions, because it can go in or out. And then it'd be greater than for the one solution. You just have to figure out that number. Woo. All right, you guys know this, man. These are beasts. Unless you realize, don't all three of these kind of form or have a pattern? You have little a, you have big A, and the other guys in between. Little b and big B. Other guys in between. Little c and big C. Other guys in between. But we still have to memorize all of those and then all of those. Unless you're really good at moving stuff and formulas. If you're really good at moving stuff, maybe you can skip that altogether. We'll have to figure out tomorrow what you need to do. The law of cosines. Bye guys, finish up this lunch. Play with your calculator. Come tomorrow if it's not working, but have whatever you typed in there because you probably are just thinking I need to see it.